So here's a system. Is it Hamiltonian? Is it gradient? We don't know. So before you try to solve, you have to know which one it is, because if you noticed from the examples that we did, there's a different treatment. The integrals aren't the same. Which one gets the dx depends on whether it's Hamiltonian or gradient. So here's the Hamiltonian test. Let's see if this one applies. Here's the gradient test. See if this one applies. So I need the partial with respect to x of this first one. So that comes out to be 6y minus 18x. Now, little g partial with respect to y is 18x minus 6y. So if you distribute this minus sign, you get the negative 18x, you get the positive 6y. The Hamiltonian checks. It's Hamiltonian, dudes. It's Hamiltonian. But we're going to do the other check anyway. Let's do the other check. This one should fail. The only time you can have a system that's both Hamiltonian and gradient is a very simple thing. Everything has to be 0. So it's not a very interesting, there's examples, but they're almost just straight linear things. There's not anything interesting going on with them. So let's do partial of f with respect to y. Partial of f with respect to y is 6x minus nothing else. Partial of g with respect to x is going to be 18y. And these are not equal. So the system is not gradient. Well, now that we know what it is, it's Hamiltonian, we can solve. And Hamiltonian means we're really just solving for the h of xy whose level curves are solution curves. So when it's on a test, you don't, even if it's a take-home test, I don't expect you to drive into a place that has a computer algebra system that's capable of graphing a surface with level curves and allows you to turn it so you can look straight down on it and see the level curves. If we were in class, I'd show you how to do that on a Maple computer, but you won't have a Maple computer probably. So we skip that part. I'll print something if I need to. So I can talk about level curves. I'll just print one on the test and you can tell me things about it. So you should look at the book pictures of level curves and what they say, be able to say similar things. So we're going to do two integrals. We're going to write this thing, but since it's Hamiltonian, it's going to be, the integral's going to be, the first one's going to be dy. So it's this thing dy. 6xy minus 9x squared plus 6 dy plus pure x. And that's supposed to be equal to the integral of this thing, 18xy minus 3y squared dx plus any pure y stuff. Now those of you who've had Calc 3 probably realize already that you've got a different number of terms here. So there's going to be at least one pure term of something. There's going to be a term of pure x or pure y because the number of terms is different. So there's got to be at least one pure term to get it so that you get a function that satisfies both of these two sides. So this side dy, I'm going to have y squared divided by 2, so it's a 3x y squared. The 6 divided by 2 is 3. Then this guy is just going to be a minus 9x squared y, and then plus a 6y. And any pure x stuff that might turn up over here, because here's the dx. Well, let's see what happens over here. When I do the dx, I'm going to get 18x squared over 2. That's a 9x squared. And you can see I've forgotten the minus sign on here because it's Hamiltonian. Oops. Make sure you remember that. So I'm going to have the minus 9x squared. Then I'm going to get a plus 3x y squared. Boola, boola. We're matching both of these. And the only difference is there's a pure y. So the pure y must be 6y. And that's our h. That's h of xy. And that's as much as I'm going to ask you because unless I graph this thing for you and ask you to draw a solution curve, which would be a level curve then. That's the most I can do because you don't have the ability to get the level curves from the surface now and see what the solution curves look like. So that's how that thing would go. One other question. The book beats this into the ground. And in case you're reading the book has this very cool dead fish gradient problem. So they do the example, they do the dead fish gradient problem, and then they have 2 homework problems that do a dead fish gradient. So I'm going to do just the overview of those things. So if you skim the book, this will sort of make sense to you. So what they did was they noticed that there's a system that if you have a surface that has a couple of bumps in it. So here's your surface, and it's got a bump here, it's got a bump here, and then it's got this kind of thing. So it's not a hyperbolic paraboloid, it's 2 bumps. It's like you have 1 bed sheet over 2 kids of different sizes. But this would be a g of xy, and the level curves look like this. The level curves look like this. When you look straight down on it, you'll see you have these concentric circles here, and these concentric circles here, and then you'll have a line running in between, and you'll have some other curves that spiral off like this. And that's what the level curves are going to look like if you think about it when you have these 2 kids under a bed sheet of different heights. Well, they can be the same height. But they call it the 2 dead fish because if you remember for a gradient problem, the solutions are perpendicular to the gradient curve. So a solution curve looks like this. A solution curve does that, or does this, depending on your initial conditions. Solution curves do this. And then there's one family of solution curves that run down the middle. And the idea is, it's as if you have 2 attractors, like I've got Bugs Bunny here. I don't know if you can read it. Well, we'll bring the camera up closer and show you the system. And you've got Daffy Duck. So what we got is this. You could be attracted to this, and if you start out kind of leaning toward getting some skag from Bugs Bunny, then you're going to go over there and get some skag. If your initial conditions have you closer to the prostitute Daffy Duck, hey baby, hey baby, hey baby, you run over this way. And then there's the case where you happen to be right down the middle and you can't decide. Should I go over to get some skag, or should I go over and entertain my other impure desires with the duck? So you have this one solution that runs down the middle, which would be this level curve there. It's not a level curve, but it's this section that runs straight. Anyway, so you have these, you have that stuff going on. You have these pieces like that. And what they compare it to is a lobster, because a lobster has these 2 antennae. And if the lobster senses something to the left stronger, it heads to the left. If it senses something to the right stronger, it heads to the right. So you have these curves, like we had before, the curves heading this way, or the curves heading this way, and they're perpendicular to the level curves. So that's what's going on with the dead fish example. And the book's extremely proud of it, so they beat it into the ground. Okay, you guys, that's it for Chapter 5, I think. See you later.